This lecture again is part of the training program for the CMIS. Sediment characteristics, I am sure the civil engineers would have gone through this under soil mechanics. We are just, I am going to just elaborate something on the marine sediments and how we carry out the analysis and where exactly all this information are applicable in the case of marine, in the case of coastal processes. If you look at the marine sediments along an open coastline, they are non-cohesive and their movement depends on the water motions as well as the physical properties of the individual particles. So, for that matter, how are these beaches formed? We have not dumped the sand there along the beach. This sand which is formed as beach, the sand, as I said earlier, would be brought by the rivers and a major portion of the sand actually comes from the seabed. How the sand lying in the deep ocean or the seabed, along the seabed, is being seen along the beach. To understand that, you should go in detail the physical processes of the interaction of waves and sediments. Simple. If the forces induced by the waves or currents, which is nothing but the driving parameters, if they are more than the size of the sediments are going to be lifted and moved. And when it is in motion, and in case at certain location along the coast, if the driving force is less and the sand characteristics, the weight or its size is bigger, naturally it will settle down. It is a very simple thing. But then we need to understand all these things because the sand characteristics or the sediment characteristics are very vital, particularly in maintaining the harbors, that is approach channels of the harbors. In order to maintain the harbor channels, maintenance dredging is needed because the vessels need certain amount of depth in order to come in and go out of the harbor. So, what happens is, as I said earlier, the sand is in motion and it will go, and these approach channels through which the ships are coming, they will act something like sinks, and if the sand moving is heavier than the flow velocity, it will slowly settle in the approach channels, and then cumulative deposition of this sand will lead to what? Will lead to increase in dredging quantities. All the major ports along the Indian coast or elsewhere all over the globe most of the ports, the major expenditure is towards maintenance dredging, and this maintenance dredging is controlled by the characteristics of the sediments. So, marine sediments on an open coastline are non-cohesive and their motion depends on wave induced motions or current induced or due to current in the open ocean. These, I said, they are the driving forces, as well as on the physical properties of individual particles. How do you assess the physical properties of individual particles? For that, you need to collect samples along the coast, followed by a rigorous analysis in the laboratory. I am sure the civil engineers must have heard these parameters. The most important parameter is the grain size or the particle size of sediments. The most frequently used parameter is the D50, that is 50% of the sand is finer. That is, you take some amount of sand sample, put it in a sieve and then drain it. The sieve also will have some size. Then percentage of sand that is retained in the sieve, that will be the measure of D50. How the sieve analysis is done, etc., that will be demonstrated by the field staff. I am just providing you some of the basic information on the sediment characteristics. In addition to the D50, two other coefficients are employed frequently. These are called as coefficient of curvature and coefficient of uniformity. The coefficient of curvature is given as D30 square divided by the product of D60 and D10, whereas the uniformity coefficient is the ratio between D60 and D10. What are these two coefficients represent? What are they representing? If the curvature coefficient is between 1 and 3, the grain size distribution curve which you see in the picture will be small, well graded, and if Cu exceeds 4, for example gravels, or 6 for example for sands, there will be a wide range of sizes, which is now we call it as poorly graded. The picture you see here is as per American Geophysical Union classification. So, clay is coarse, then silt we can have a classification as very fine, medium and coarse. Similarly, sand you can have very fine, medium and coarse, and also very coarse, and then similarly you have gravel. So, this picture is a view of this classification, so that you have an idea what we are talking about. In a beach where you have very fine sand, will it serve its purpose for tourism or relaxation? Because when the sand is very fine, this can easily be drifted away by the wind also. If it is too coarse, it is not a pleasantable beach. In between, if you have medium size sand, maybe it is a via media, and that will anyway, whether it is core, definitely when you consider fine and medium, these two beaches are supposed to be the kind of beaches where we would like to relax. So, cobbles and gravel, you can see all these things can easily be moved by the waves and currents. So, this also gives us an idea about what is the kind of force the waves and currents can induce on these kind of particles. Salient sediment properties. In a marine environment, quartz sand and clay are predominant. For instance, clay, the typical grain size will be less than 0.63 millimeters, 0.6 millimeters. The effect of a coefficient plays an important role in sediment transport process. Fine sand, in which case the particle size should be between 0.3 to 0.6 mm, they are the easiest to erode. Larger particles are more difficult to lift even for a high erosion velocity, which is a known fact. Finer material will describes smooth profile, that is less affected by turbulence. Further, unconsolidated silt and clay can erode even at lower velocities. These are some of the salient properties of sediments. Now, there is yet another parameter used for sedimentation. See, there are two parameters. One is the submerged weight of the sand. The other one is the fall velocity. What is fall velocity? The velocity with which the sand is going to go down towards the seabed. If the velocity is fast, it will go down fast. When will the velocity be fast? When it depends on the grain size. Now, in order to understand this, we talk about what is called as buoyancy index. Buoyancy index is nothing but it is something to do with the submerged weight of the particle. The buoyant index is shown on the screen, the formula where nu is the kinematic viscosity and ds is the d50. In general, the ratio of gamma s, which is the specific weight of sphere divided by the specific weight of fluid, is greater than 1. What happens? The sediment particle will be heavier than the water. The submerged weight of the particle is also proportional to the d cubed, the diameter. I mean the diameter of the sphere or the d50. And the fall velocity will decrease with an increase in viscosity of the water, that also we know. Now, you see, for smaller buoyancy index, look at the formula. For smaller buoyancy index, what does that indicate? That indicates smaller falling velocity, and larger buoyancy index results in larger fall velocity. So, you can equate the buoyancy index with fall velocity, and you can determine the fall velocity, which I will not be covering here. Based on the buoyancy index, the fall velocity can be calculated. What exactly is the fall velocity? The fall velocity tells the suspension time of a particle in water after it is suspended in a water column. I hope it is clear. If one knows the current or the wave induced velocity, particle velocity, the movement of sand or the movement of the particle in the horizontal direction can easily be computed. So, now you understand what is important. We need the specific weight of the sand, we need the grain size of the sand, only then we will be in a position to understand how the sand is moving, where the sand is likely to go, how much sand will be depositing, etc., can be calculated. So, the movement of sand takes place in three forms. One is the bed load, then the suspended load, and then wash load. What is bed load? The bed load, in the form of bed load, the sand will be moving in the form of sliding, rolling or saltation. The zone is closer to the bed surface. Thickness is about 1 to 3 times the particle diameter, I mean d50. Suspended load, sediment supported by turbulent eddies, movement is in suspension. So, it will be moving near the surface. High shear velocity, more suspended load. Then finally, we have what is called as wash velocity, eroded and washed away from the bed, hardly gets deposited in the channel, it keeps on moving, not considered for calculation for if you want to understand what is the bed load, bed level changes, it is not going to be of any use, the wash load. So, finally, when we look at the stability of a coastal area in general, I am telling, which also includes the approach channels near ports, the bed load and the suspended load is extremely important to evaluate, which is governed directly by the grain size. I am sure that this explains the importance of sediment characteristics. Why do we need the sediment characteristics? There are a number of reasons why we need to know the sediment characteristics. To estimate, first thing is, maybe I will say for one by one, to estimate because if I start giving an example for each of this, then I will be running out of time. As I said earlier, all these things, all whatever I have just said, the details are available in my lecture under NPTEL of IIT Madras. Just look at coastal engineering, you put my name, you are going to get a number of modules. Look at it and then get back to me in case of any doubts or clarifications. First and foremost is the sediment characteristics are needed to estimate the sediment transport rate along the coast. For your information, earlier in I would say till late 90s, when the direct measurement of waves and currents etc. were not so easy and popular, people were relying only on the visually observed wave data and the ship observed wave data, but through which they had estimated the sediment characteristics or the sediment transport rate. And it was reported to be anywhere between 0.8 to 1.2 million meter cube per year, for example, along the east coast of India. But then when we used the instrumental measured data, for some stretches we have found that there is an overestimate of about 30%, 30 to 40% overestimate through visually observed data. This explains the importance of actual field data, and also this grain size also is important. As you can see in the buoyancy index, the D50 is raised to the power 3. Next is to estimate the dredging quantities in approach channels, harbors, inlets. Maintenance of tidal inlets is a very big issue, particularly at locations where the river flow is less and the tidal range is also less. When the tidal range and the river flow both are less, whereas the wave activity is continuous, then what will happen is the sand will come and deposit in the mouth, a spit will be formed, the mouth will be closed. Once the mouth is closed, the connection between the ocean and the river is gone. And once that is gone, the water in the river will remain as a pool of water, stagnant water. And all of you know what is the problem with stagnant water. So there has been a number of mitigation measures tried for some of the inlets all over the globe, and many of them have failed. Of late, there are some techniques mostly connected with because the refinement of the parameters that are dictating the coastal sediment transport help us in carefully designing the training walls, which is one of the pioneering method. Properly designing the training wall, and also the other important remedial measure being the artificial beach nourishment. These both techniques have become quite handy now, mainly because of the careful assigning of values for the parameters that are dictating the movement of sediments. In that way, estimation of dredging quantities and approach channels and harbors, etc., is important, for which the sediment characteristics play a very important role. Next, once dredging is done, the maintenance dredging, then you need to dump it inside the ocean, for example. Then in that case you have to identify dumping grounds, and when you want to identify dumping grounds, you look for depth where the initiation of sediment motion is going to take place. So this can be easily calculated once you have the sediment characteristics and the flow parameters. Flow parameters means wave flow parameters. And once this depth of initiation is known, probably you look at that option of trying to dispose the dredged spoil beyond that depth, provided the lead distance is not too much. So this helps in identifying the dumping grounds for the disposal of dredged spoil. Finally, to develop artificial islands, artificial airports, the talk of the day, talk of these years. Artificial islands and have come in a very big way in the Gulf as well as in Japan, where there are a number of airports also. So in the design of all these things, the sediment characteristics are of great importance. So analysis, the most common method is the particle size distribution, which I have already explained. So you use a sediment size distribution by sieving. The most common method is by sieving and plotting the results as weight of material that is retained against a sieve single size, because the sieve size should be of same size, and then to produce a cumulative size frequency curve. You can refer to any standard soil mechanics book or my lectures in the NPTEL program of IIT Madras. So procedures and operating principles will be explained by the CMIS staff on the data. So then this was, I think, now I move on to the collection of sediment samples. Onshore and onshore sediment samples under this project are collected at selected transects, one along the surf zone and other at the foreshore. Before doing so, surface soil is removed up to about 0.5 meters with the help of a scoop or core cutter, and then the soil sample is taken. The samples below the 0.5 meters are collected, packed, transported immediately, and then it is a rigorous analysis is carried out in the laboratory to assess the particle size distribution along with the specific gravity, which is also very important for calculating the buoyancy index.
So at each predefined transect, we will be collecting two samples, one at the foreshore and the other at the surfing zone. So you can see on the beach where the wave starts breaking, that's called a surfing zone, and we'll be taking the sediment sample over there, and the other sample at the berm. You can see the berm in the shoreline. You can see, you can actually see the variations along the berm. It will start descending so fast. So, and that's the mark for us to point the zone.
Hello.
So, in order to take the sediment sample, first we need a packing device. So I mean the package to seal the sediment you'll be taking. So I have a Ziploc cover with me and a stainless steel scoop with me to scoop up the soil. So I have two Ziploc covers, one kept inside the other one, and a name tag denoting the soil and at which and the location of the soil. So I had kept this name tag in between two Ziploc covers. In order to obtain the sample, first I am going to take the sample at the berm. Here at the berm, I have to first mark a location, and I will first remove the top 50 centimeters of the soil. In general, 30 to 50 centimeters of the top soil is removed in order to obtain the sample which we will be testing in the lab. Also make sure that the soil is free from debris such as seashells and other stuff. So I have now dug a hole up to 50 centimeters deep in the berm, and now I will be taking the sample. So generally we will be requiring half kilo to 1 kg of the sample from the site in order to test the soil for obtaining the grain size distribution of the sediment sample. So scoop up the sample and put it in the cover. Now I have obtained the sample that is equivalent to 1 kg of normal sand. Now you have to seal the cover with the help of a rubber band
to avoid spillage of sand while transporting it to the lab. Make sure that the name tag is visible. And now we have obtained the sample from the berm.
Similarly, we will be taking sample from the offshore area also. Again, we will be marking the location, scoop up the soil up to 0.5 meter in the soil, and we'll be taking out the sample. And in a similar way, in a similar packing method, we will be taking the sample from the nearshore, from the offshore area, and both of these samples will be sent to the lab for further testing to obtain the grain size distribution and the specific gravity of the soil. So generally, P50 is the main parameter which we will be identifying from the soil sample. So that P50 parameter is the parameter that is essential to test, essential parameter for solving all the coastal problems that are associated with shore activities.
Now we are going to collect onshore samples. That is onshore samples at this berm and this here to the shore. So the purpose of collecting this onshore sample is for determining the gradation of the soil. So using the grain size analysis and then specific gravity and all, we will see how the soil is well graded or poorly graded. Like that we will differentiate the soil grades. So this gradation and this grain size distribution things and all we needed for constructing the coastal structures. So in our project we are collecting this onshore and then both offshore also. So in onshore we first we will collect that near to the berm, and second we will collect near to the shore. So these are the bags. We will collect samples, soil samples. So in this I have there will be a notation. You can see KP1 PS, that means Characteistic Transect 1, berm sample. And then in a next bag I have entered as
KT1 SS,
KT1 SS, that is Caracal T Transact 1 shore sample. So these are the Ziploc covers. So I have
taken two covers.
I have taken two covers in which these are for the safety of our samples, because some samples will have we will collect with the water also. So for safety of the samples only, I have taken two covers, one in another.
So our labels will
So our labels will be in between
one
ones.
cover. So that our labels will
won't
be washed off.
won't be washed
So
off.
now we are going to
So
collect
now
the
we are going to collect the
sample.
berm sample.
Now is collecting berm
Now is
sample
collecting berm
using
sample
scoop.
using scoop.
So
Normal methodology for collecting the onshore sample is we have to remove of the
disturbed soils.
disturbed soils. So disturbed soil means due to wave actions and means the top surface will be usually goes on disturbance. So we have to remove of the disturbed soils. For that is for up to 0.3 meters we have to dig it, so that we can get the undisturbed soil samples for our analysis.
So is now
Now collecting using the scoop.
Okay, ma.
So is now collecting the sample of Ziploc covers.
So up to 500
So up to 500 grams, 300 to 500 grams we will collect these samples. Okay. Now we have to lock it. Since it is Ziploc cover, we can easily lock it.
So after locking the
So after locking the inside cover, the outer cover may be locked with a rubber band.
Okay, now he is collecting.
Okay, now he is collecting
samples near to the shore.
samples near to the shore.
So here also we have.
So here also we have to take off the
soil.
disturbed soils.
So, but mostly.
But mostly
very near
this
to
is
the
near,
shore.
very near to the shore.
While
So
digging up to
while digging up to 0.1 or even 0.05 meters, we can get a nearshore sample. By collecting nearshore sample, we will get water seeping the hole.
So at that
So
point,
at that point we can collect these samples.
over we are going to try it.
Over we are going to try it in oven only. So no problem.
So same as
berm sample. This also need to be
collected up to
collected up to 500 grams.
So first is
zipping the inside cover. Now he's going to
lock the
outer cover with the rubber band
for the safety of the.
for the safety of the sediment.
So this is the out.
So this
So
is the
this
out.
is our shore
So this
sample.
is our shore sample.
KTSS.
KTSS.
And this is our berm sample.
And this is our berm
KT1
sample.
BS.
KT1 BS.
So that's our onshore.
So that's our onshore samples are collected.